Okay, now we're recording homework review for Monday, October 12th. Homework number 11. We had section 3.2 problem sets, 1 through 16 all. So for 1, 2, 3, 4, for right and left hand derivatives, you're asked to compare them and show the functions not differentiable at a certain point. So that's where I said you could just use the results from the notes from section 3.1 to kind of just help you with that. Like, yes, that's gonna be a derivative of 1 over here. And that's derivative 2x. And you know x equals 0, so obviously that's going to be a derivative of 0 and derivative of 1 still here. So that's why it's not differentiable. Here, that's the slope of 0, that's the slope of 2, not differentiable there. Here, we have those results from the notes. I think that was 1 over 2 root x. So that's the slope of 1/2 here at x equals 1, that's the slope of 2, not the same. Here, that's a linear function with a slope of 1. 1 over x, that result was 1 over, what was that? -1 over x squared was 0 of 1 over x. At x equals 1, that's going to be -1. So again, those slopes are not the same either. So you didn't have to actually find these by hand. You could just use the results from our notes and say, well, I know the derivative from 1 over x, so we did in the notes. Then 1 over x squared, if I plug in x equals 1, that slope is -1. Whereas here, it's a linear function, that's 1. So that's all you're doing for 1, 2, 3, 4. You're simply just figuring out what the derivatives are for left right hand derivatives for point P, and then plug in the x value and just showing that they're not the same. So for that was pretty straightforward there. It's a great question actually. For number 1, 4, do we have to establish continuity first before find left and right hand derivatives? Yes, you do have to establish continuity. And you could just do a quick check. You could just say f of 0 exists. The limit as x approaches 0 of f of x exists, and f is 0 equals that limit. Yes, you should always do that first. Now, the purpose of this question, you already knew they were not differentiable. So, I mean, they look continuous. So you could just go straight. If you didn't do that in the homework, don't worry. If you just did what I just talked about, find left right hand derivatives, that's okay. On a test, I'll probably do these multiple parts and say, is this continuous? Go through those 3 conditions, and then do the differentiability part. Now, if it's not continuous, then of course you stop right there. But you're specifically asked to find right and left hand derivatives, so the assumption was they were continuous. So you didn't really have to show that. But yes, as a habit, you should always go through this process. So thank you for bringing that up. For 5, 6, 7, 8, someone asked about 8a. So first off, you're going based on looks. That's all you can do. I didn't put any hints here, but should talk about it. So you're just going based off looks. Like this, it's pretty clear this is a line segment. It's continuous, right? So we're just gonna say, yeah, it's differentiable everywhere because I don't see any reason why it would not be differentiable. If it's continuous but not differentiable, well, no, because it's differentiable everywhere. And C is no. So it's just the line, like we don't have any issues. Remember, differentiability is going to happen 4 ways. If you have discontinuities anywhere, if you have a corner, a cusp, vertical tangent. So those are the 4 ways we got to look for. I didn't see that happening in number 5, and nor did number 6. Number 6 is a nice, smooth, polynomial, whatever, curve. So yeah, it's differential everywhere, and B and C are no. Now 7, it's not differentiable because we do have a discontinuity. Where's this discontinuity? At x equals 0. So we're definitely going to say at x equals 0, it's not differentiable. Now, is there any place where it's continuous but not differentiable? Well, the only place where not differentiable is x equals 0 because of discontinuity. So you're going to say no for B. And C, of course, is x equals 0 because it was both not continuous and not differentiable. Now, 8's a little weird. I see 2 discontinuities at 0 and at 2. And I do see a corner at x equals 2. So first off, we're not differentiable at 3 places. -1, 0, and 2. Again, 0 and 2 because of lack of continuity. -1 because of a corner. So different reasons for those points. Now for B, you're asking, are you continuous but not differentiable? Yes, you are at -1. We are continuous. I see it looks continuous. I see it defined at -1. I see the limit existing at -1 and the limit equaling f of -1. I see that. But not differentiable because the left right hand derivatives are different. In fact, the left hand derivative here is going to be -3. The right hand derivative here is +3. Not the same, not differentiable. That's how we define differentiability. The left right hand derivatives have to equal each other. That's how we defined it. So B will be -1, obviously. For C, where you're not differential, not continuous, obviously you're not continuous at 0 and 2, so naturally you're not differential there either. So that's why it's C for that one. How do you know one's a corner and not an absolute value graph? Well, absolute value graphs are corners, same thing. So the question is, how do you know one's a corner and not absolute value graph, something like that? Corners are continuous. Absolute value functions are continuous. Absolute value functions are never, ever differential to vertex. Never, ever, never. So they're actually the same thing. They're not different. So yeah, that's an absolute value. I totally, if I want to write a piecewise function for number 8, I could have written as f of x equals the absolute value of x plus 1 from -2 to 0. I totally could have done that, and then and then this is a parabola afterwards, and I kind of have that part. Or I could have done this. That's going to be, I think it's going to hit the y-axis at -3 here. So I could have written this as I'm sorry, I meant to say 3x plus 1, my bad. I think, no, 3 on the outside. My bad, I wrote that incorrectly. Or I could have written as -3x minus 3 and 3x plus 3 as 2 linear functions. I could have done that too. This would have been true if x is between -2 and -1. And that would have been true from -1 to 0. Actually, I don't have an equal sign there. Regardless, it's still the same thing. You still get the same scenario. You still get left-hand right-hand derivatives being different. So it doesn't matter. And of course, again, going back to C again, x equals 0 and 2 are not continuous, not differentiable. So hopefully that helped a little bit with understanding the connection, the relation between continuity and differentiable. Remember, if you're continuous, you're not necessarily differentiable. Like we're continuous at -1, but we're not differentiable there. If you're differentiable everywhere, then you are continuous. So when you have lack of continuity, you don't have differentiability, like in the case of 0 and 2 here, or 0 for number 7. And then the other one is 11 through 16. Again, there was, I think, a question there in the chat. No, there wasn't, but we'll just go over that very quickly. And by the way, well, I didn't mean to put a heart stamp. That's okay. Okay, why is it doing that? Okay, here we go. 11 through 16, I just said use Desmos. You could do piecewise function. If you just do a quick Google search, it shows you how to do it. I always forget how to do it, so I always have to do a Google search, and then it tells me what to do. But you will see that there's a discontinuity for sure. And 12, you'll see a cusp if you were to graph that in Desmos. If you did the other ones, these two would be corners, and this would be a vertical tangent. That'd be a cusp. So you kind of I just want to just graph and just state. That's all. Any question about 11 through 16? Now, one thing we are going to do, we'll do this down the road. When you start learning more derivative techniques, I will just give you just a random function, and I'll say, tell me where this is not differentiable. Here I'm telling you it's not differentiable at x equals 0, and then to give me a reason. But now, well, not now, but down the road, as you learn more derivative techniques, you will actually be asked to do that. Here's just a function. But again, when you learn the techniques, you'll be fine. There's a certain process that goes into that. But we'll get there probably not until December, I think. After Thanksgiving, we'll do that kind of stuff. All right, anyway, so that's homework review. So stop sharing. Let me stop that recording.